Alright, here's the next part of the Algebra 1 video on variation. This one is inverse variation, whereas the last one was direct variation. So they're both conceptually and mathematically similar with one key difference. So in the previous video, what we learned before was direct variation. That was where things were, quote, direct, which means when one went up, the other went up, or if one went down, the other went down. And here it's inverse, which kind of means opposite. So with inverse variation, when one variable goes up, the other variable is going to go down, but it's again by the same ratio. So for example, if one variable gets times by 3, the other one will get divided by 3 or multiplied by 1/3, because that's the same thing. And so the equation, instead of being y equals k times x, now the equation is y equals k divided by x. So this is going to be a huge difference mathematically when we're solving them. Let me get my colors here. The fact that the x is now in the denominator is going to make a big difference when we're solving these equations and how we do it. K is still the constant of proportionality, which means in a given problem it's going to have the same value, but from one problem to the next problem it could change. So x and y are the two variables, and they'll change even within the same problem. They're both variables that can fluctuate. So a couple of examples to get your mind in the mode of inverse variation. Speed and time for a given distance. So if you have a certain distance that you want to drive, say for example from your house to school, and suppose you start driving faster, if you increase your speed, what happens to the time it takes to get there? Well, it's going to be less. So if you drive twice as fast, you're going to take half as much time to get there. So if one of them is multiplied by 2, the other was divided by 2. Another example that you probably all know of, but you may not have noticed that it's inverse variation, is when you open a door, the distance away from the hinge is inversely proportional to the force you need to apply to open the door. So what that means is, if you push really close to the hinge, it's going to take, so the distance is very small, it's going to take a very large force to open the door, but if you push very far away from the door, it's going to take a very small force. So this is why handles are always located on the opposite side of the hinge. And you can try this at home, just find a door somewhere and try to open it by pushing really close to the hinge and then by pushing farther away, and you'll notice, you may not be able to calculate it, but you'll notice that the farther away you push, the less force is needed. And this last one, it's not mathematically exactly inverse variation, but it will help get your mind in the right mindset. Experience and mistakes. So the more experience you have, the less mistakes you will make. This one, the reason it's not exactly inverse variation is because if you have twice as much experience, it's not guaranteed that you'll make exactly half as many mistakes. So it's not perfect inverse variation, but it gets your mind in the idea of one thing is going up, the other thing is going down. Okay, let's do a couple of math problems. Just like before with direct variation, typically what you'll want to do first is set up your equation and solve for the value of k. And once you know the value of k, then you can use that value to solve for the unknown. So suppose x and y vary inversely. So as soon as they tell you that, you pop up with your equation, y equals k divided by x. Okay. When y equals 5, x is 15. So we can plug that in. 5 equals k over 15. Okay, so what does that mean? That means k equals, well, how do we solve for k? We need to multiply both sides by 15. Cancel. Multiply over here by 15. What's 15 times 5? Okay, 15 times 5 is 75. So we found our k value to be 75. That's the constant of proportionality. So now we can move on to the second part and answer the question. What is the y value when x is 30? Okay, so y equals k over x. K we just found out was 75, and x is given to us as 30. Okay, so y equals 75 over 30. Type in your calculator or do it in your head, and you will get 2.5. Okay, so 2.5. So now let's analyze it in the other way, just like I had done with the direct variation. When one variable goes up, the other variable goes down by the same ratio. Okay, so let's look at this problem here with that mindset. So the x value starts at 15 and it ends at 30. So what happened to x? X doubles. Okay, so if the x variable went up twice as much, the y variable has to go down twice as much. So if the y variable here started off as 5 and it goes down twice as much, it's going to end up at 2.5. So the math and the equation verifies your intuition based on the concept of what inverse variation is about. Okay, let's do one more example. Suppose x and y vary inversely. Bam, y equals k over x. It should be automatic for you guys. As soon as you see it varies inversely, you write down y equals k over x. And likewise, if you see varies directly, you write down y equals k times x. Okay, when x equals 100, y equals 1. Okay, 1 equals k over 100. So we're just plugging in the numerical value for x as 100 and y as 1, which allows us to solve for k. And k equals 100. Just multiply both sides by 100 here. Now that we know the value of k, we can plug that in to find the value of x. So y is 3.5, so 3.5 equals k, which we just found out to be 100, divided by x, which is the unknown. Okay, and now here's where a lot of people start making mistakes, which is what makes inverse variation tricky. The variable, the unknown variable here, is in the denominator, and so you can't just divide both sides by 100 and be done. You can't multiply both sides by 100 and done. You have this predicament because your unknown is in the denominator. Okay, when we say solve for a certain variable, that variable has to be in the numerator. So in fact, when we have something like this, the first thing you actually do is you multiply both sides by x. And what that does is it moves the variable from the denominator into the numerator. So now this is gone. And you have x times 3.5 equals 100. So I'll write that as 3.5x equals 100. Okay, and now you're all comfortable dividing by 3.5. Divide by 3.5. And our answer is x equals, calculator time, 100 divided by 3.5, 28.6. Okay, 28.6. And we've got our answer. But again, I want to reiterate, when you have inverse variation and your variable or your unknown is in the denominator, it's incredibly important that you make sure you remember to multiply both sides by that variable to get it in the numerator. Alternatively, you could think of this as a 3.5 over 1, and then you could cross multiply, which is essentially what I'm doing, right? 3.5 times x is this cross here, and 1 times 100 is this cross here. So 3.5x equals 100. But you need to get the variable out of the denominator into the numerator before you can actually solve for it. Okay? And our last thing, just like with direct variation, is the alternate formulation for it. So let me show here. We have this equation, y equals kx. And if we have y equals kx, I'll write it here again, y equals kx, k divided by x. Y equals k divided by x. If you multiply both sides times x, okay, then these cancel out, and you're left with k, which is constant, equal to xy. Okay, so the product, the multiplication of your two variables, x times y, has to be a constant. So what that means is x1 times y1 should equal x2 times y2. Okay, so if you know the x value and the y value at the beginning, one way to do it was how I did it here. Plug in x and y and find the unknown k value as your intermediate answer. And then for the second part, you can use that value of k that you just found to figure out your unknown. Alternatively, you can skip that intermediate step by just setting up x1, y1 equals x2, y2. But this is only available as an option for inverse variation. And so what happens sometimes to students, and I want you to be careful it doesn't happen to you, is you get mixed up with inverse variation and direct variation, which one is the ratio equals the ratio, and which one is the product equals the product. So for inverse variation, it's actually a product that's constant, whereas for direct variation, it's a ratio that's constant. And those concepts in your head, like when you think of inverse, you think of fractions, and so it's easy to get mixed up. So just be extra careful doing it this way. And again, let me reiterate the importance of always checking your answer for common sense. With inverse variation, when one variable goes up, the other variable has to go down. So let's use this one as an example. The value of y, it was y equals 1, and it ended up with y equals 3.5. Okay, so the y value went up, so the x value has to go down. So it went from 100 down to 28.6. So that at least checks out your common sense of one thing going up and the other going down. if you use this shortcuts wrong, what will happen is both will go up, and you should immediately catch yourself and say, okay, if it's inverse variation, I know that I can't have both of them go up, and then you can recheck your work or do it the long way with the actual formula and the intermediate value of k. Okay, make sure you fill out the form, and I look forward to helping you guys out in class.